In this video, we're going to talk about function notation. So here's some function notation basics. First of all, function notation looks like this, and it's read f of x. F of x represents a second variable, usually y, but not always. And the variable inside the parentheses is always found on the other side of the equation. So our first couple of examples, we're simply going to translate these equations into function notation. So we're replacing y with f of x because the x is the variable on the other side of the equation. So f of x is equal to 2/3 x plus 8. It's important to note that in the past, parentheses have meant multiplication. So if you have a number right next to a number in parentheses, that would be multiplication. In this case, it's not. This is one singular variable. So y gets changed directly into f of x. So there's no multiplication happening here. It's just f of x, one variable. All right. This one right here, a equals 7 plus b. We're going to translate this. The variable that's on the opposite side of the equation is b, so this is going to be f of b is 7 plus b. And in this case, f of b replaces a instead of y. So again, it usually replaces y, but it just depends on the individual problem. Last example, we have a y equals x divided by 4 plus 9. X is the variable on the other side of the equation, so this is going to be f of y is equal to, f of x is replacing the y, so f of x is equal to x divided by 4 plus 9. Alright, simplifying. The problem or equation is known as a function rule. Given the domain, substitute each value and evaluate. This will produce the range. Alright, so here's an example problem and a couple of steps. It says 1, substitute the first given value into the function rule. So the first given value in my domain here, again, this is the domain, it's given, right? You can recognize the set builder notation, x when x exists, and it's -2, 0, and 3. So we're substituting in -2. Be sure to use parentheses when you're substituting, so we did that here. Step 2, use the calculator to evaluate the expression. Remember, f of x is a variable and cannot be evaluated, so we're not doing anything over here. It's just f of -2 is equal to x. We replace x with -2, both on the left hand and on the right hand side. And then step 3, repeat the process for each of the remaining domain numbers. So we would use 0 and 3. And write your answers as a range. Make sure it's in increasing order and there's no repeats. And then I always like to put a box around your answer just to make it stand out. Alright, let's try a couple. So on the next page, we have f of x is equal to 9 minus x, and my domain is -5, 0, and 2. So I'm going to start by plugging in each of those values. Let me turn this just a little so it's easier for me to write here. There we go. Alright, so the first one is f of -5. So I'm replacing x with -5 is equal to 9 minus -5. And 9 minus -5 is like 9 plus 5, so f of -5 would be 14. Alright, the next one that I have to do is f of 0, so f of 0 is equal to 9 minus 0, and that's going to be 9. And the last one is f of 2, so 9 minus 2 means f of 2 is going to equal 7. So then I'm going to write that in set builder notation for the range. So range y when y is, and we're doing least to greatest, so 7, 9, 14. And that's my answer for the first example. Alright, second example, I have f of x equals x squared minus 1. So I'm going to plug in these values again. So f of -5 is equal to -5 squared minus 1. Notice I'm plugging in parentheses. -5 squared is -5 times -5, which is going to give me a positive 25, and 25 minus 1 is 24. All right, the next one is 0. F of 0 is 0 squared minus 1. 0 squared is 0, and 0 minus 1 is -1. The last one is f of 2. So I have 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. So my range would be y when y exists is least to greatest. So I need to start with the -1. I'm breaking my own rules here. Actually, they're not my rules. They're the math rules, but should not be broken. Least to greatest, I'm starting with -1, and then 3, and then 24. All right, graphing. It says use the rule to find the range, and then you plot all the coordinates on the coordinate grid. So here's an example with the steps. Step 1, it says use the given domain in the function. Use the given domain in the function rule to find the range. Remember that the domain is the x value and that the range is the y value. And then step 2, plot the points on the graph. And step 3, draw the line or the curve through the points. So there's that one right there. Notice here's your domain. They plugged in each of the numbers. They came up with the range, the 4, the 3, and the 2. They wrote them as ordered pairs, and then they plotted their graph. All right, so last example for us today. I have f of x equals x squared minus 2, and I have -1, 0, and 1 that I'm plugging in. So I'm going to start with f of -1. Remember to plug in parentheses. So this is -1 squared, which is a +1. +1 minus 2 is a -1. So my ordered pair, x is -1, y is also -1. So -1, -1. So -1, -1 is right about there. All right, the next one is f of 0. So I have 0 squared minus 2. 0 squared is 0. And 0 minus 2 is -2, so my ordered pair is 0, -2. 0, -2. And the last one is f of 1. So I have 1 squared minus 2. 1 squared is 1. And 1 minus 2 is not -2. It's -1. Right. So my ordered pair would be 1, -1. I'm going over to 1 and down to -1. And this is going to make a curve, like a U. It's actually called a parabola, and we'll learn more about that as the year goes on.